Welcome to Concrete Programming in C++. And today I'm going to do a very quick overview of overloading functions, and then we're going to talk about the rule of three. So let's get into what overloading is, because it's going to be important for what we're doing today. So in this example, I have two constructors for a student class called student with no arguments, which is called a no argument constructor. And I've got student with an int and a const char star. So I'm passing two parameters. So the second function that you see is a two argument constructor. But in reality, they're just functions. And so in this other example, what I want to do is show you that I've created a struct called distance, and inside I've got two data types, an int feet and a float inches. And below that I've got two prototypes for functions called dist. And notice that they're both called dist, and they both are just passing one argument. Okay? It's a little bit different than the first example I showed you with student, where I was showing you a no argument constructor and a two argument constructor. In this particular case, it's actually just a one argument function, but they're both called dist. Okay? The difference is in overloading, I'm also able to pass different data types as my arguments through the actual function call. So whether I have no arguments or I have 1, 2, or 5 or 10 arguments to pass through a function, it doesn't matter. I can still name it the same. And in this distance or dist function example, I've got one argument, but I'm passing different data types through it. So that's why I'm allowed to do that. So if I actually look at the implementation of each of those two functions, you notice that I'm in the first one passing the struct distance as dd, and the second one I'm passing float as dd. Okay, they're two separate individual functions. They just happen to have the same name. I'm actually allowed to do this. I'm allowed to overload the constructor. Okay, and if we go to main and I instantiate distance d1 or float d2, and then I pass in the d1.feet and d1.inches, or I do a cin statement and I ask the user for those values, and then I do the same thing. I asked the user for values for it to put into d2. You'll notice that in both cases, my functions that I'm now going to call, they automatically know which function they're calling based on the type of data member that I'm passing through the function. That's why you see in these two cases that the first one automatically knew to select D1 because of the way the definition of the first function was written. I passed through the struct distance through it. And in the second one, it automatically knew because I was passing the float. And so when I asked my user to input information like feet and inches, it automatically knew what I was trying to pass into my function overloads. So that's something that you need to be aware of. Overloading functions is pretty common in C++, and I hope in this video I can show you how Microsoft Visual Studio will allow you to cycle through all of the different function overloads. I've seen some function overloads in Visual Studio where there was up to 21 different overloads for the same function name. So when we get into doing some real coding in here, we can have a look at that. So enough on overloading. What I really want to do is talk about something called the rule of three. Okay, and down in the bottom corner on the right side, I've got a YouTube link, and I'll include it in the description. It's for a person who did a lot of C++ YouTube videos years ago, and his work was exceptional. I thought he did a great job of explaining things, but for some reason he's no longer active on YouTube. He's not producing any more C++ videos, which is kind of a shame because his stuff is high quality and it's outstanding. So a lot of this video is based off of, or loosely based off of, the video that I've included in here and on the description. I feel it's appropriate to give him credit for what he had done, but I'm gonna take his just a couple steps further and show how I want to show it for my purposes. And so we're going to start with the rule of three. And the rule of three really comes down to three very, very important functions. And the first one is the copy constructor. Okay, the second one is called the assignment operator. And then finally, the third one is called the delete constructor, or the deconstructor. Now, in the last video when we talked about destructors, I think I made a statement where I said it's not normal that we do a lot of programming inside the destructor. But this is an example of where we do have to go in and write some code inside of our destructor. And we're going to get into that. It's pretty simple. It's not a lot that we have to do into the destructor, but the other two functions are quite heavy. But these are three very, very special functions that we have to do whenever we are dealing with dynamic memory. Okay, so let's look at an example here. And let's suppose we have a class called character. It's got 4 data types: name, life, strength, intelligence, and string int, and int. Okay, and we create a character, we instantiate a character called C1, and we give him a name Bob, life of 7, strength 5, and intelligence 6. Then we create another character, and that's going to be Joe, 8, 8, and 6. Okay, all of this right now is on the stack. It's important to understand this is not dynamic memory. This is all on the stack. So we have created C1, and it looks like this as a memory model. And we also have C2. Okay, again, this is what it looks like as a memory model. It too is on the stack. So what happens when I do the following though? What happens when I assign C2 to C1? Now remember, this is assignment. This is not equal to. I'm not comparing. I'm not saying C1 equals 2. What I'm saying is take the right hand value of C2 and assign it to the value of C1. Okay? So it's a very important distinction, and I covered that in a previous video. So if I'm in this situation now where I say C2 assigned to C1, you realize now that C2 and C1 are identical. C2 is now Joe, C1 is now Joe. There's no more Bob. Okay? So character 1 is Joe, character 2 is now Joe. Okay? This is what we refer to as a shallow copy. Okay, and it'll be more clear to you why this is a shallow copy in a minute. Okay, so if we look at our class character right now, and we go one step further, and we do this. I now introduce a tool array, okay, from a different class called tool. It's got its own address, right? And now C2 also has its own address. So then we come back to C1 and we look at what it's pointing to. I've got this heap, and in the heap I'm storing different objects. So in this particular case, Bob has access to a weapon or a tool, which is an axe, and it's referencing by the address 0x9AB. Okay, it's out on the heap. And C2, Joe, has his own tools, his own array of tools. He's got a potion, a crossbow, and maybe a candle. Okay, and notice these are both on the heap. I'm just going to clean that up a little bit. What happens now when I do C2 equals C1, but I'm dealing with heap space. I'm dealing with dynamic memory, or at least a pointer, or a resource. This is what happens. Okay? They are both now pointing to the same memory address. And again, we refer to this as a shallow copy. So what we have to do is, to get a deep copy, we need a overloaded assignment operator for the character class. Okay, and so this is what we're trying to achieve now, is that both of my characters that were instantiated as from C2 equals C1, they're both now pointing to different areas on the heap. Okay, notice they're both Joe 866, but their addresses are pointing to a different spot in memory, as denoted by the memory addresses. Okay, so if we assume the overloaded assignment operator has been written, we end up in this other situation. Okay, we're going to take this a little one step further. Okay, so what happens now when I do this? C2 equals C3. Okay, and what I'm doing here in this line of code is I'm instantiating character C3 at the exact same time I'm assigning C2 to its value. Okay, C2 already exists, but we want to create C3. Now what? Even if we don't have the overloaded assignment operator, it won't get called because C3 doesn't exist. And that's why we need the copy constructor. Okay, and that's what's going to get invoked. So if we don't write our own copy constructor, C++ provides a default copy constructor, and unfortunately it will only provide another shallow copy. So if you look here, C2 equals C3, you're seeing them both point to the same memory address on the heap. And then again, we're back into a shallow copy. Okay, so an issue is that C3 doesn't exist before character C3 can be assigned the value of C2. So we need to write our own copy constructor for the character class to perform a deep copy. Okay, so now what happens when we delete, or we call the delete on C2? Remember, C2 is what we were assigning to C3. But what happens when we perform a delete on C2? Okay, the default constructor gets invoked. And look what happens. We lose our pointer. Okay, we lose access to that heap. And so as a result, we get garbage on the heap. Okay, and if you've done Java, you've probably heard about garbage collection being automatic and all that stuff. And this is what you're hearing about, is this very idea of garbage being left out on the heap. And luckily, Java takes care of all this stuff for you. But C++ does not. You, as the developer, have to go and address this. Okay, so we need to write our own destructor for the character class to delete data that may be referenced by a member on the heap. Okay, so the question is now, when do we write the rule of 3? And the answer is whenever we have a class that has members that can reference heap space, which means dynamic memory. So let's talk a little bit about class resources. Sometimes we will know the amount of memory that an object requires during runtime, not as early as compile time. Memory that an object allocates at runtime represents a resource of that object's class. And as we get into more examples, all this written text that you're hearing me read to you is going to become more clear, because I'm pretty sure you're going to have to watch this video more than one time to get the entire foundational knowledge into your brain, because this is a lot of stuff to absorb, and you're not going to get it just the first time. The management of this resource requires additional logic that was unnecessary for simpler classes. So if you think about right in the beginning when I had just the character C1, the name, life, strength, and intelligence, that was a simple class, okay? This is a little more complex now that we've introduced heap space and dynamic memory. This additional logic ensures proper handling of the resource and is often called deep copying and assignment. So if we look at an example, static memory for grade. So in the previous implementation, grade was an array of characters with predetermined length 14. I may have had that set to 4 or 14. It doesn't really matter for what we're doing. So our class looked a lot like this. It was a student number in their grade. We had a no argument constructor, we had a 2-argument constructor, and then we were just displaying. And you see at the bottom we're instantiating Harry, John, Mary, and X. Okay, but what if we want to allocate dynamic memory for grade, right? How do we handle that? So our resource instant pointer is the answer. And what we need to do is we need a pointer for allocating dynamic memory. The allocated memory is called a resource, and the pointer is called a resource instance pointer. Okay, and that's what this is right here. It is a char star grade. So we convert that array over to a pointer. Okay, and a C++ object refers to a resource through a resource instance pointer. The pointer holds the address of the resource. So the address lies outside the object's static memory. So have a look at this chart. On the left you see static memory, and on the right you're seeing dynamic. So number in both cases for Harry is static, but grade becomes dynamic. Let's go over to Visual Studio and look at some examples. So here we are in our student class. And what I showed before was that this char star was actually an array of, and it had a size of 14. And for this, what I'm doing is like I said previously, I'm converting it to a char star grade as a resource. Okay, this is my pointer now. And I've changed up some of these functions a little bit here as well. And I still have my no argument constructor here. I've got a 2-argument constructor. And down on the bottom, I've got this display. And at the very bottom, I have this safe empty state. I'm going to save the safe empty state because I want to show you how to do refactoring. Okay. And so for now, what I want to do, the first thing is quickly show that I have these 3 functions that I talked about, the rule of 3. So the first one is I've got my copy constructor. And like I said before, it's your type, const, type, and the ampersand. So when you see that syntax, you know that you're automatically dealing with a copy constructor. Okay, that's the C++ syntax for a copy constructor. Now the second one is the assignment operator. Okay, and look at this special syntax. It's the class type, okay, and which I should mention that these data types that I'm talking about, notice that they are all part of the class data type, okay? So we're in student, ampersand, and this is what you need to, when you see this operator equals, you'll know that it's the assignment operator. And remember, equals is when we talk about doing assignment. So that's how you can tell that that's the assignment operator. And then inside the brackets, it's actually identical to the copy constructor, okay? Because what I'm trying to do is copy and assign, right? And then finally, we have this here, okay? It's the student destructor. And we're gonna go in and have a look at all of these things. But I wanna show you this little trick that you may or may not know about Visual Studio. But if you highlight over something, okay, over a function for an example, you can right click on it and it'll say go to definition. Okay, I click on that. What it did is it brought me over to the student.cpp file, right to the function that I had highlighted. So what I was saying is, hey, I see you've written in the function inside of the class H file, but I want to go to that source and see what it looks like in the actual implementation code. Okay, what I'd like to do is very quickly, I want to talk about this safe empty state. Okay, and what this function is ultimately is I've got the two data types that I'm interested. I've got my pointer and I've got my number. Okay, and because I know number is just a normal integer variable, I'm going to set that to 0. And my grade I know is a pointer, so I'm initializing this to a null pointer. Okay, and by doing this, I put both my number and my grade into something called a safe empty state. Okay, it's there. I've made the grade pointer equal to null pointer, which we talked about in the last video, that's always a great coding practice because unpredictable things can happen. So that's what I've done in this here. And I want to show you this this neat little trick that you can do. Okay, I'm gonna get rid of this. I'm gonna delete all that stuff. I'm just gonna delete it altogether. Okay, I would actually have that up in my no argument constructor. Okay, this is what that no argument constructor would typically look like. But because I have to, in more than one location, reset my variables to a safe empty state, I'm going to convert this to a function so that I can just keep calling the function and I don't have to keep redoing this. Now remember, I'm doing this with only 2 member variables. Okay, you could have 5 or 6. So this would become very cumbersome if I had to keep doing this over and over and over when I know that I'm just assigning it to either 0 or to a null pointer. So in order to be efficient with my programming, I want to be have code reusability. I'm going to highlight that inside these code brackets, and it usually has to be inside code brackets. Okay, I'm going to highlight that. I'm going to go to edit, and down on the bottom, I'm going to do something called refactoring, and I'm going to extract the method. And I'm going to call this safe empty. I'll just leave it as safe empty so that I can show you the contrast. And I'll put it below it. It doesn't matter where it goes. But what it did is it took those member functions that I wanted and it wrapped it around the function definition or prototype. And then what it left in its spot was the actual function call. Okay, and it opened up the function, which is in my CPP file. It opened it up for me to look at. So that's great. It's in there. Now, if I go back down to my into my CPP file and now I look for it, you see that it's right there. That whole entire function call is there. And I'm going to take that and I'm going to Control X that, drop it over top of this. I'm going to get rid of that safe empty. Okay, so when I did that, if you notice up here, I've got this safe empty state. and it's going to be looking for it. I'm going to get an error in a minute. But notice now in my header file, in the header file itself, it created the function prototype for me. Okay, this one I can take out, that's the old one. And what I'll do is I'll move this down to the bottom. Okay, but I need to use it, okay, because I don't want to have to keep setting it to a safe empty state. So here you see where I got the error because that function no longer exists. So because I used it, I'll put the old prototype back in there, get rid of void, and now I'm as good as new, right? So if ever in my code again I need to call or do a safe empty state, I can just call that function and put that in its place. I've only had to write that code one time, and I've used it in 2 other locations. So that's a handy little thing that Visual Studio does. I don't know what the other IDEs do, but I really like that. Okay, so let's get back to the real intent of this video anyway. So I've got my no argument constructor, and all I wanted to do with that is set it to a safe state. Okay, and if we go down to our 2 argument constructor now, what I'm doing is I'm writing this sort of syntax. Okay, I've got my grade here, my const sharp star. Okay, and I've written this function here, and I'm not going to get too deep into this specific function too much, other than to say that I need this for doing some assignment or some copying. Okay, it's I need this function to do the rest of the stuff. So it might become a little more clear to you as we go along, but for now, just understand what I'm trying to do. And notice this keyword right here, new. Okay, when you see new, that's an indication that somewhere out there I'm dealing with dynamic memory, right? Okay, so what I really want to do is talk about my first one, which is the copy constructor. So we need to talk a little bit about this deep copy and deep assignment. Okay, so if we change the resource data in one object, we expect the resource data in the other object to remain unchanged. In copying and assigning objects, we ensure this resource independence through deep copies and deep assignments. Okay, so deep copies and assignments involve copying the resource data. Shallow copies and assignments, which involve copying the instance variables only, are only appropriate for classes without resources. So if you look at this little diagram here, on the left again you got shallow copy, and on the right you've got deep copy. And notice with the deep copy we're using our pointers for our pointer resources. Okay, so it's a vastly different thing that we're trying to do because of the heap space, and we're going to get back into the code in a moment so that we can figure out how this syntax all goes together and how this exactly works from a mechanical point of view. So if we talk about the copy constructor, the copy constructor defines the logic for copying from a source object to a newly created object of the same type. The compiler calls this constructor under 3 conditions. Okay, whenever we initialize an object at creation, copy an object by value in a function call, and return an object by value from an object. Okay, that's when we're using this copy constructor. And syntactically, it looks like this: type, brackets, const, type, ampersand. Okay, so don't get too concerned about what the prototype of this function declaration looks like. It's not really an important detail, believe it or not, and you'll probably go crazy trying to figure out every little nut and bolt of this declaration. But the important thing to take away is that when you see this syntax, you know that you're dealing with a copy constructor. And the big giveaway is the ampersand on the end. Okay, so we're going to go ahead and look at a Visual Studio example of the copy constructor for our student class. Let's get into Visual Studio now. Okay, and here's the syntax in the definition. And what I'm doing here is I'm trying to pass in this source. Okay, and I'm saying source dot number, and I'm assigning it to number. Okay, that's a shallow copy, but it's a little bit different now, because if I'm trying to do the same thing with my dynamic memory, let me put a space in there. I'm trying to do this with my dynamic memory. Now look at the difference here, right? What I'm saying is if my source dot grade is not equal to null pointer, okay, then perform this operation here, okay, which is a grade, a new char. This stands for string length, okay, source dot grade, and then I'm just adding one from my null. Okay, so copy data from the original source to the newly allocated resource. And then that's what this string copy is. And if this string copy gives you any problems because it's old, go to the very top and add this define. Okay, it's underscore CTR, and you can search for it online. It's there. It's an old throwback from C and C++. And C++ now finds it to be a little bit risky, but you can still use string copy, but you're better off to add that line. Now there's another more modern one. It's strn, so it would be n and underscore s. The only difference is, you can see, is that I'm missing an actual parameter. What it wants from me is to add an extra parameter. Now, remember earlier when I said that Visual Studio will give you options for your function overloading. So that's why I talked about overloading in the beginning. Notice that I've got these up arrows. This is two versions of the string copy function. And I'm in one of two, and now I'm in the two of two. So these are my two options. This is what I could choose from to call that function. Okay, and the second one wants me to do this really ugly looking line of code, this r size underscore t max count. Don't worry about it. Okay, so let's get out of there and go back to normal and just stay with what works. But all that to say is that the first thing I'm doing is my shallow copy, and then I'm allocating dynamic memory for my grade string. And I'm checking to see if grade is set to a null pointer, and then I am copying data from the original source to the newly allocated source. And then else I've got this grade is set to null pointer. Okay, so that's the syntax for my copy constructor. So the assignment operator, so let's go look at that again. But before we do, there's a couple of things I want to say, in that the assignment operator defines the logic for copying data from an existing object to another existing object. So think back when I was saying C1 equals C2. Okay, I'm copying data from an existing object to another existing object, right? So that's the key takeaway there, is that both of the objects already existed in that particular case. So the compiler calls this member operator whenever we write expressions in the form of this. So identifier 1, identifier 2. So that's the same as saying C1 equals C2. Remember, both of those already existed when I did the assignment. It wasn't until later when I did C3 that C3 wasn't in existence yet. That's a different situation. So the definition of the assignment operator contains logic that does the following. It checks for self-assignment. It shallow copies the non-resource instance variables to destination variables. So it's copying things like name, life, strength, and intelligence. Okay. It deallocates any previously allocated resource for the current object. Allocates a new resource for the current object. So as you've probably detected by now, there's just a sequence, there's almost an algorithm to this function. Okay, it copies resource data associated with the source object to the newly allocated resource memory of the current object. Now, I fully appreciate that is a mouthful, okay? But in the code, we'll look at how this all works. So I want to go back up to the first bullet point there though, and I want to talk about self-assignment because I don't want to miss it. And the question is, must we check for self-assignment? And the answer is absolutely, we absolutely have to, okay? And we do it with an if statement. And we're saying if this does not equal to ampersand source. Okay, and we're going to write that actual function, or we're going to write that actual self-assignment, and I'm going to put it into a function itself more than likely. But I don't know because I'm not there yet. So if we don't check, the deallocation statement would deallocate the memory holding the resource data, and we would lose access to the resource. We'd lose access to the pointer. Okay, so that's why we have to check for self-assignment. And think about this for a minute. Okay, my name is Tom, and I try to make myself equal to myself. Okay, I need to check that the user's not trying to say, okay, Tom equals Tom. Okay, we have to check for that because it has a consequence. And if we don't address it, then we lose access to our resource. So what we're really interested in is what happens when Sima equals Tom. That's what we're really interested in. But for now, we have to address this just in case somebody tries to make me equal to myself. Okay, let's go back over to Visual Studio and look at the rest of this code. Okay, and look at all the steps inside the assignment operator. First thing I want to do, and I mentioned this previously, is I want to check for self-assignment. And that's this line of code right here. Okay, this is where I said, does Tom equal to Tom? Okay, so if Tom does not equal to Tom, great. Then do a shallow copy of the non-resource variables. Okay, and all that is very similar to the setter and getter operations you're accustomed to. But what I'm saying is source dot, which is this source, dot number, and assign it over to number. Then I'm saying deallocate previously allocated dynamic memory, okay, which is delete bracket grade. Now allocate new dynamic memory if needed. Okay, and remember what I said earlier, you're going to have to watch this video again to not just get the syntax but get deeper meaning. Do a deep copy on your understanding of what's going on. Okay, so at this point now I'm saying, is the source.grade not equal to null pointer? Okay, and if it's not, perform this operation. Copy the resource data. Okay, this is the source data, this, and I want to copy it over to here. And then else, just do the grade null pointer. And finish this function off with a return statement, the star or asterisk this. Okay, it's important that you include this line at the end. Okay, this is a star. This should not be return this. Okay, you need this. Okay, so I've got a simple display function in here, and I'm actually doing the ternary operator for this. It's the WTF, and I hope you understand my meaning. It's the what, true, and false. Okay. Now, the last thing, okay, the last thing we got to do is our destructor. Okay. In the rule of 3, this is the last of the 3 things we have to do. We have to call the delete on that grade. Okay? It's an important step. Okay, let's go have a look at main, and I'm going to show you what I'm trying to do with main. Okay, so first thing I'm doing is I'm creating student S1, and I'll give them this big long student number and all these grades. And then I'm saying, okay, display it. And then again, I'm going to do student 2, okay, and 2.display, and we'll see what happens. Okay, and then we're going to get into this, and then we'll see what happens. Okay, and let me block that one for a minute too. Okay, so let's just see what happens. Okay, pretty straightforward. It called the display function and it took our 2 things. So we know that it's has no problem taking the student number and the dynamically allocated space for the grades. And notice I purposely created the grade length a different number, or a different number of student grades. Okay, so let's do this. Okay, let's take this out and see what happens. Okay, that worked as well. What happened is we created the first 2 objects and we gave them student number and grades, and then I assigned S1 to be the value of S2. Okay, so when we displayed S2 right here, notice we're getting the output of what is S1. Okay, so that worked. All right, now let's go have a look at this and see what happens. Okay, here's the result. Here's S1, here's S2. Here is S1 being assigned to S2 and then displayed. I instantiated S3 while simultaneously copying all of the variables, the member variables from S1, and assigning it to S3 at the same time. Okay, and I was able to do that. And then I called the S3 display, and notice that that's what we've got. Okay, so this all worked. We were able to successfully use the rule of 3 with dynamic memory. Okay, so I would strongly go through. I hope you can see the code. I'll scroll through really quickly for you. All right. Don't forget to add this sign if you're having a problem with string copy. Okay. Here is my code for doing the 2 argument constructor. Okay, and I want you to notice something. When you compile this, if you have an E, if there's an E inside this, there's a failing grade. Okay, it is actually going to send you to the test, and you'll see down in this display function, when you call the display function, okay, you're gonna have a printout of this and you'll get a 0. Okay, so that's what this line of code is also taking care of. Okay, so that's only if you award, I think, an E. Okay, so there's your 2 argument constructor. Let's go to the copy constructor, and here's the syntax for your copy constructor that I'm using. Okay, and I want to highlight that this code inside is the same as in here. The only thing that's different is the operator with the equals, and this is just being called on student. Okay, and then this operator with the equals. Okay, and then look at this syntax here, and by all means do not forget this final line. Okay, and finally the destructor. You've got delete with grade. Okay, and then I hope you appreciate how Visual Studio can do these refactoring of functions for you, because you'll recall them. Because if you had a whole bunch of variables in here, this would be very cumbersome to try and program. Okay, so that concludes all of the Visual Studio part. So what we've talked about is the rule of three. Okay, and we went through the copy constructor, the assignment operator, and then again we talked about the delete constructor or the deconstructor. Okay, and these are very important functions when dealing with heap space, okay, or dynamic memory. So these have to actually be called. So anytime that you would see somebody saying, hey, I have a requirement for dynamic memory, which is almost always, this is when we have to start thinking about the rule of three. Okay, it's the copy constructor, the assignment operator, and the delete constructor. Okay, so we've covered that in a lot of depth, and thanks for watching. I hope you got a lot out of this, and I strongly recommend that you re-watch this video a couple of times, because it's a little bit tricky. It's not the most intuitive. It's not the easiest thing to do, but you've got the resource there. Go ahead, watch this, and I would recommend following along with the code and trying to produce the same thing I am and do all of your own debugging. But for now, thanks for sticking with the video and watching, and have a good day, and I'll see you in the next video. Thank you.